Look up on a clear night far from the city, and you will see a few thousand stars. That is all your eyes can manage, a scattering of points of light separated by vast oceans of black. It feels obvious. Of course, the night is dark. The sun has set, and the stars are far away, too faint and too few to light the world. But there is a problem hidden in that darkness, a problem so deep that some of the sharpest minds in history lost sleep over it. Because the universe is not nearly empty. It is filled with stars. Hundreds of billions of them in our galaxy alone, and somewhere between 100 billion and 2 trillion galaxies beyond it. If the universe goes on forever, and for centuries the greatest astronomers assumed it did, then no matter which direction you look, your line of sight should eventually land on the surface of a star. Every single point in the sky. Every gap between the stars you can see. All of it should be burning. The night sky should not be dark at all. It should be a wall of blinding fire, as bright as the surface of the sun in every direction all the time. And yet, it isn't. That contradiction has a name. And to understand why the darkness above you is one of the most important clues we have ever found about the universe, we have to go back to a quiet German astronomer who stared into the night and realized something was very wrong. The puzzle is older than you might think. As far back as 1610, Johannes Kepler, the man who worked out how the planets move, looked at the dark night sky and drew a strange conclusion from it. To him, the darkness was proof that the universe could not be infinite. It had to have an edge, a finite box of stars surrounded by nothing. Others disagreed. They imagined an endless cosmos stretching out in every direction without limit, sprinkled evenly with stars forever. And that beautiful idea carried a hidden cost, one that took 2 more centuries to fully sink in. In 1823, a German physician and astronomer named Heinrich Olbers laid the problem out so clearly that it still carries his name today. We call it Olbers Paradox, though, as is so often the way in science, he was far from the first to notice it. Here is the heart of it. Picture the universe as infinite and ageless, with stars scattered through it more or less evenly. Now imagine standing at the center and looking outward in one exact direction. Maybe the nearest star along that line is close and bright. Maybe it is far and faint. But if space goes on forever, then sooner or later, near or unimaginably distant, that line must strike the glowing surface of some star. There is no escaping it. It is like standing in an endless forest. No matter where you turn, eventually your gaze lands on a tree trunk. You can never see out. The trees fill every angle. In an infinite universe of stars, every angle is filled too. Not with trunks, with suns. And that means the entire sky, every tiny patch of it, should shine with the brightness of a stellar surface. Day and night would lose all meaning. The earth would be scorched by light pouring in from every direction at once. So why are we sitting here in the cool and the dark looking up at mostly black? Something in that tidy, infinite picture has to be wrong. The only question is what? The first instinct is the obvious one. Distant stars are fainter. Surely the faraway ones are simply too dim to matter. And it is true that light fades with distance. A star twice as far away appears 4 times fainter. 4 times as far, 16 times fainter. The brightness drops off as the square of the distance, fast. But this is where the paradox sharpens into something genuinely unsettling. Because the fading does not save you. Think about a thin shell of space around you like the skin of a bubble at some fixed distance. The stars in that shell are each dimmed by their distance, yes. But a shell farther out is also larger. It has more room in it, and so it holds more stars. In fact, it holds exactly enough more stars to cancel the dimming out. The light from each star falls as the square of the distance. The number of stars in the shell grows as the square of the distance. The two effects are mirror images. They erase each other perfectly. So every shell of space, near or far, contributes the same total amount of light to your sky. The shell 100 light-years out. The shell 1,000,000 light-years out. The shell 1,000,000,000. Each one adds the same glow. And in an infinite universe, there are infinitely many shells. Add up an endless series of equal contributions, and the answer runs off to infinity. The math is merciless. A truly infinite, eternal, star-filled universe should drown you in light without limit. And it is worse than a faint background glow. If every line of sight ends on a star, the sky would not merely be lit, it would be saturated. Stack enough stellar surfaces one behind another in every direction, and there is no patch of black left to hide in. The whole dome of the heavens would shine with the full ferocity of a sun's face. The ground beneath you would be hotter than an oven. Nothing alive could survive a single night under a sky like that. People tried to wriggle out of it. Maybe, they said, clouds of dust and gas drift between the stars, soaking up the excess light and shielding us. For a while, that felt like an answer. It wasn't. Because light carries energy, and energy cannot simply vanish. If dust stood in the path of all that starlight, century after century, it would absorb that energy and heat up until it glowed just as brightly as the stars it was hiding. You cannot smother a fire by wrapping it in a blanket forever. Eventually, the blanket catches. The Swiss astronomer Jean-Philippe de Chézeaux had run into this same wall back in the 1700s. He even proposed the absorbing dust idea himself, but it could not save the theory. The darkness refused to be explained away. And then, from the most unexpected direction imaginable, came a glimpse of the real answer, not from an astronomer at all, but from a poet. In 1848, the writer Edgar Allan Poe, yes, the man who gave us tales of ravens and beating hearts, published a strange, sprawling prose poem about the nature of the cosmos. He called it Eureka. Buried inside it was an idea decades ahead of its time. Poe reasoned that the reason we see darkness between the stars is that the light from the most distant ones has simply not arrived yet. The void we see, he suggested, is not empty. It is a place from which light is still on its way. He had no telescope capable of proving it. He had only intuition. But he had quietly put his finger on the truth. To see why Poe was right, you have to give up one of the oldest assumptions human beings ever made about the sky. We assumed the universe was eternal, that it had always been here, unchanging, with the stars burning forever. It hasn't. The universe had a beginning. Our best measurements place it at around 13.8 billion years ago, the event we now call the Big Bang. And that single fact detonates the entire paradox, because light does not travel instantly. It moves fast, but it has a speed limit. And so when you look out into space, you are never seeing the present. You are looking backward in time. The farther away something is, the older its light. See a star 1,000 light years away, and you see it as it was 1,000 years ago. Look at a galaxy 10 billion light years off, and you are watching light that left it 10 billion years in the past. But here is the wall. If the universe is only 13.8 billion years old, then there has not been enough time for the light from more distant objects to reach us at all. Beyond a certain distance, that light is still in transit. It has not crossed the gulf yet. There is, in effect, a horizon around us. Not the edge of the universe itself, but the edge of the part we can possibly see. And within that horizon, the number of stars is not infinite. It is large beyond imagining, but finite. That is what breaks the paradox. The endless sum of shells does not run to infinity because the shells run out. The universe simply has not been shining long enough to fill the sky. This was not just a hand wave. Around the turn of the 20th century, the physicist Lord Kelvin actually ran the numbers working out how far light could have traveled and how many stars could possibly lie within reach. He confirmed that there were nowhere near enough of them in the time available to set the whole sky alight. The darkness was not a flaw to be patched. It was exactly what a young universe should look like. But it gets stranger. There is a second reason the night stays dark, and it comes from the fact that the universe is not standing still. It is expanding. Every distant galaxy is rushing away from us, and the most distant ones are receding fastest of all. When a source of light races away from you, its light is stretched. The waves are pulled longer, sliding from blue toward red, and then past red entirely out of visible light altogether into the infrared and beyond. So even the light that does manage to reach us from the deepest distances arrives drained and reddened, its energy stretched so thin that our eyes can no longer register it at all. The universe is not only too young to fill the sky with fire, it is actively dimming the fire that remains, redshifting it into invisibility. You can almost watch this happen. Point a powerful telescope at a patch of sky that looks utterly black, a tiny window of apparent nothingness, and hold it there, gathering light for days. Slowly, the darkness fills in. Thousands of faint galaxies emerge from what looked like empty void, each one billions of light years away, their light so stretched and so dim that no human eye could ever have caught it. The black was never empty. It was only too faint and too far to see. And that raises one final, haunting question. If the deepest light has been stretched out of sight, is it truly gone? Or is the sky out there blazing after all, just in a kind of light we were never built to see? It turns out the answer is the second one. And it is one of the most beautiful discoveries in the history of science. In 1965, two radio astronomers named Arno Penzias and Robert Wilson, working with a large horn-shaped antenna, kept picking up a faint hiss they could not get rid of. It came from every direction in the sky, evenly, no matter where they pointed the dish. They checked the equipment. They cleaned out nesting pigeons. The hiss remained. What they had stumbled onto was the oldest light in existence. In its first moments, the entire universe was unimaginably hot and dense, a glowing fog of plasma blazing like the surface of a star, filling all of space. For a few 100,000 years, the whole cosmos was on fire, in every direction at once, exactly the way Olbers Paradox predicted the sky should be. That fire never went out. It is still here. It still fills the entire sky in every direction, just as the paradox demanded. But across 13.8 billion years, the expansion of the universe has stretched that ancient blaze more than 1,000-fold, cooling it from the heat of a star down to just a few degrees above absolute zero. The fire is still there. Its light has simply been pulled so far that it now glows not in visible light, but in faint microwaves. We call it the cosmic microwave background. And here is the quiet miracle of it. Olbers was right. The entire night sky is glowing. Every point of it. The wall of fire he predicted truly exists, surrounding us completely. We were simply looking with the wrong eyes. The darkness you see is not the absence of that glow. It is the glow, redshifted into a color we cannot perceive. The blackness between the stars is not empty. It is the faded light of the beginning of everything. So the next time you stand beneath a clear night sky and see all that darkness, remember what it is actually telling you. That darkness is not nothing. It is the single most powerful piece of evidence we have that the universe had a birth, that time itself began, that the stars have not always been here, and that we live inside something with an age and an edge to what it can show us. For thousands of years, human beings looked up, saw the dark, and assumed it was simply the empty backdrop against which the stars were hung. The plain, featureless absence of light. It was the opposite. The darkness was the message. It was the universe telling us, in the only language it had, that it was young and growing, and that it began. A man named Heinrich Olbers asked why the night is dark, and thought he had found a paradox. What he had really found was a door. And every clear night, that door is open above your head, a quiet reminder that even emptiness has a story, if you know how to read it. Thanks for watching. If a question like this is the kind of thing that keeps you up at night, subscribe. There are more of these waiting. Until then, keep looking up.